Now, so here, because we are concatenating axis is 0, we are kind of plonking into the rows. Then concat will look at the columns, right? So we're not going to create you know, multiple column names. So here, when we say join is inner, we are asking pandas to sort of look carefully. Only when you have some sort of intersection, commonality. Inner means intersection. Think of it that way. All right, inner, because it's a historical development, started with calling it inner join, but you can think of it not as a new concept, but as an intersection of the columns. Columns, huh? Because for now the axis is 0, and if you have axis is 1, it will be the row index labels. So here are the column index labels. If you say find the intersection of column index labels between BD and CD, well, it's D. So which means you want to extract the common column labels. Then you force concatenate. So it will end up as 2789, right? And then 28, because the common labels are like that. This is quite neat if you want to sort of find intersection, extract common columns, no matter where they are located, so long as there's a D and a D, right? And if you have BCD, then B and D will be common. But right now we only have D, right? And then you also notice that the DF1 is listed first with duplicated index values. That's okay, because when we say axis is 0, we are plonking row-wise, and therefore column values have to be unique. Row labels, like this case, can be repeated. So if you're plonking row-wise, row labels can be repeated. Now what happens if you say axis is 1? Then if you're plonking column-wise, then column labels can be repeated. Okay, so literally, as we see now, PD concat df1, df2, axis is 1. Row labels are now unique because we are plonking column-wise, and column labels may be duplicated because it's like a false copy. Just drop it in, but pay attention to the rows because they should be unique. Yeah. So notice also that the df2 here, when we put axis is 1, right? It goes up here, 0, 1. Why doesn't 2278 go to rows 4 and 5, creating more rows? Why don't we do that? That's because we have common row labels, and row labels cannot be duplicated. Because imagine if 2278 were to go down, you, or rather pandas, doesn't have the authority to create 4 and 5, right? Because it has to preserve the integrity and content of the original data frame. So it is forced, it will be forced to call the row labels 0, 1, 2, 3, 0, 1 rather than 4, 5. But wait, it is not a row-wise concatenation. It is a column-wise concatenation where the row labels have to be unique. So it is unable to oblige 0, 1, 2, 3, 0, 1. Yeah, earlier case is okay because axis is 0. Now its axis is 1. Means pay attention to the row labels must be unique, but column labels can be duplicated. Okay, so remember that. Now, of course, if we change the row labels to 4, 5, then yeah, it will be moved down to create 2 more rows. And then you have more nans along the way. So last combination where everything is there. So PD concat df1, df2, inner. We want common what? Common column values or row labels? Row labels, because axis is 1. So likewise, we now apply the intersection thing, the concept, not to the column labels, can be duplicated, can exist multiple times, but to the row label. So 0, 1 and 0, 1, those are common. So extract those columns out. We get BD and then CD, and make no attempt to disambiguate the D's here because it's a axis 1 operation. Okay. Next, let's look at merge. In merge, as compared to column, as I put a very important warning sign here. Column concat only aligns the label values. They are not going to touch the content. So it is not going to inspect the 2, 7. Oh, there is a 2 and a 2 here, and the D columns, the 2 and the 2 here, the 8 and the 8 here. So let me just do that. No, it's not going to inspect the cell content. Yeah. As opposed to merge, which first of all operates on columns only. So there's no sense of axis and all that. And don't try to do that because it's really designed for column kind of thinking. And secondly, it does look at the content value. Now, if you're familiar with a bit of the SQL speak, the structured query language for databases, you will kind of think about the inner join and outer join kind of operations. And that is pretty much the case here. So merge is in a way Panda's way of simulating SQL inner join, outer join. And those are definitely column-based operations. Okay. Now let's look at this example, right? Okay, so we just look at this classroom simulation run first, and then we'll go and try it out in the lab in a while. So again, create df1, df2, same as before. Some commonalities like D and then shared content 2828 and different shape just to see the effects. Then we merge. Now notice that merge here is no longer at the top level pandas PD. This is very much a 2 data frame only operations. So you don't merge df1 dot merge df2 comma df3. No, don't do that. It's very much the concept is just thinking about having 2 data frames, 2 and only 2. Okay, so we say the left, we call that the left. df1 is the left data frame, is to dot merge with df2, the right data frame. And obviously, because of the merge in the middle, df1 is left, df2 is right. So you need to specify a bit more information because merge will look at the columns to see how to make things kind of right for us. So we say merge, go and look at the contents. All right, the left hand side, that means df1, look at column D. The right hand side, all right, don't necessarily go by default column D. We can say the right hand side, even though there's a D, actually what we are looking at is the C. Now why? Because sometimes, as I said, the data frames can come from different sources, and the second source may not be controllable by you. So when you download that data frame, you get what you get, right? And sometimes people might call, for example, vaccination date, vaccination date. Some other sources might record vaccination date as checked date. So, but then they write in the text file documenting that check date means vaccination date. So when you perform this kind of merging operations, you really have to specify which column and which column. So this is what it means. Left on D, look at df1, look at D. Right on whatever is on the right side, that means df2, look at column C. Okay, then inspect the contents. Now, the content values, that is 2789 and 27, the content values, are we going to take the union of them all? All right, that means only 2789 in this case because it's union. Are we going to take basically the outer union? That means 272789, 2789 then 27. That means even if it's duplicated, we also take it. Or are we going to take the intersection? So when there is 27 and 27, we keep the 27. How should we behave? How should merge behave? That is the question here. So like I said earlier on, think of inner, the how part is to indicate, just spell out, all right? Inner or outer will do. So when you say inner means intersection. So which means the intersection not based on the index value labels, not based on the column because we already said D and C. There's nothing to intersect. It's not empty set. But based on the content data, so dot merge really inspects the content data and then decide what to do. So the inner will teach merge to behave with an intersection kind of calculation. So 2 and 7, 2 and 7, they are intersection, right? That's the result left over. So it's going to have 2 and 7. Now, left on D, so we look at D2789, right on C, and we have 2728. Okay. Definitely, definitely the 27 in D and 27 in C, they are common. And so we will retain the C here. All right, that's for sure, right? Because this is inner merge. So we retain the column C here. We retain the B as a result because 2 and 2 match, 7 and 7 match. So we retain the B column. We'll retain whatever is the left on and the right on as well. Okay. Now, turns out that the left on D is 27, which will keep. But then if we call the right column also D, then there will be a clash. Pandas actually can tolerate that. Okay, so we understand now why we have 3127, 2728. But why is the label being changed from dx to dy? That's because actually pandas can keep it that way, BDCD, no problem. The only thing is that it wouldn't quite work very well with the kind of behavior in SQL database where the columns are uniquely named all the time. So in order to unclash it, you pandas the merge function actually will auto append something to disambiguate the columns. Okay. There are other attributes in dot merge that allow you to set the underscore x to something else. Like I don't like underscore x. I like it to be underscore 1 underscore 2. Then you can set that. But that is beside the point. Usually we can just leave it as it is. Okay. So that's for merge. So far, I hope you can see the difference now between concat and merge. Very drastic difference, right? This is column based by content of the data. Okay, now let's try again on a similar operation, but now everything is the same except we change from a how to treat the left on and right on data values. Okay, the two columns. So very much it's about the two columns. How do you treat them? If it's on outer, then it's a union. Then it's a union. When it's a union means 27 and 27. You don't duplicate them, right? You unionize them. So we will keep 27. All right, 27, we'll keep them. And we'll keep 3127 here, and then 28. Okay, so far so good. But there are also other values because we said left on D, right? D has got other values and C has got none, nothing else. So we will keep the 8 and 9 in left on and keep them. And then copy whatever is in B because we are keeping the whole data frame. And right on, we have nothing. So C is ending there. D, therefore, for the df2 also has nothing there. So we'll fill with nans, as in this case. Okay, and the 2 and 3, they came from df1. So merge is not going to arbitrarily create new labels like that. And again, the column labels are going to be disambiguated by x and y. Now you might be wondering, I mean, some of you are thinking very fast. What about index labels? What if they are duplicated? Remember, the dot merge is not meant for row-based operations. So don't think about that. It won't happen. And if you want that to happen, just transpose the data frame, use a dot merge based on column operations, get your results, then transpose back, and you'll be able to get it done.